Welcome, everybody, to the Salty Nerd Podcast Late Night Edition. I'm your host, as always, Alex, the Salty Nerd. I have a very special episode in store for you guys tonight. It's going to be a ton of fun. I'm really glad to see you guys in the chat already. This is wonderful. All right, guys, here's the deal. We're going to be discussing Leonardo DiCaprio and Jennifer Lawrence's new movie on Netflix, Don't Look Up. The movie takes a satirical look at the current social media crazed world that we live in and the hyper idolized or hyper political ideology. I can't even talk right now. That's how I'm doing great already. We're going to be talking about that movie. It has a satirical look at the world that we live in now, but the most important thing that I want to talk about tonight is the science behind the movie. And we actually have an expert with us tonight who can verify or destroy this movie's science and how it all works and give us an insight into what the real world scientific community works, how they work, and how they collaborate with the political sphere and all kinds of good stuff. So without further ado, I am proud to be able to welcome Dr. Thomas Targett to the show. Welcome, sir. He is an associate professor of astrophysics. Welcome, sir. How are you doing?
It's great to be back. Last time we spoke, you had a bucket on your head and you were pretty grumpy. So look, I'm assuming I'll get the same treatment tonight.
No, I'm much happier tonight. I'm in my own home. I don't have a freaking thing on my face. I'm good.
You hung over too, pretty bad. So it was,
Right on. And also joining us tonight, friend of the podcast, Ricky from After the Weekend. Welcome, sir. How are you doing, bud?
Good. Thank you for having me. Excited to be here tonight.
Great. All right. Tom, before we dive super deep into this movie, why don't you introduce yourself to the crew that's watching tonight? Who are you? What's your pedigree like? What's your background in astrophysics?
Sure. I'm Tom Targett. I have a PhD in astrophysics from the University of Edinburgh. I currently teach at a state university, so I really appreciated all the jokes in the movie, ragging on professors at state universities as opposed to the Ivy League. So that was kind of fun. I teach a whole range of courses from calculus-based physics to introductory astronomy to cosmology to really sort of fun stuff. And I really enjoy talking to people about science. I'm obviously huge Star Trek fan, huge sci-fi fan, and it's great to be able to talk to an audience about fun stuff like this. It's just brilliant.
Yeah, most you were talking before we started recording that most of the time you have people who pay to be in your classes, so they have to listen to you. So it's nice to be able to have people watch and listen just for fun, because that's science. I think should be fun. I think that's a really important thing to put out there in the world. Is science is freaking cool.
I sort of have a philosophy that nothing mandatory can be fun. And so, when it comes to teaching classes, I really love all the questions I get, but they have to be there. And there's an element of we're here for the grade. Whereas with the audience, I think it's brilliant because they're choosing to be here. So hopefully, unless they all leave, but fingers crossed, we can be entertaining enough.
Awesome. I just want to say hi to the chat real quick. We've got the Dork Knight himself is in the chat, and he has been drinking. Good to see you, buddy. I love the new logo, by the way. It looks great. Also, Joker Voice is in here as well. How are you doing, buddy? Yes, we have The Science is here tonight. And let's see, Luna Girl, friend of the podcast. Hello, everybody. And JT, he wished he could have been here tonight. I did invite him, but he's traveling, so he couldn't make it on. But thank you guys all so much for being in the chat. Feel free, guys, if you have a question related to the science of this movie, please post it in the comments if I can find it. And if it's not already on my list of questions to ask, I will bring it up, and we'll have a good time having a conversation with an expert. I'm so excited to have you on, Tom. This is so cool.
That's good. Good to see you.
All right, so let's dive right into this movie. The opening scene of this movie is a young scientist who is looking at the stars through this giant telescope, and she discovers something a little odd, and it turns out to be a comet. And they start going through the montage of like figuring out where it is, how big it is, what its trajectory is. And the first thing I wanted to ask was, what is the process like of actually finding an asteroid or a comet? Is it as easy as it's depicted in the movie, or is it like a longer process?
I think they actually did a pretty good job with this. I mean, I'll actually tip my hat to the science consultant on this. The strange thing is they got so many of the small details right, but so many of the really big picture things wrong. So I think it's a good starting point. I mean, when it comes to finding these things, there are whole telescope missions who are looking for them because they are dangerous. There's been a serious impact on our planet many times before, and it's had all these impacts. So we have whole missions looking for these things in space, and we know of thousands and thousands of objects that actually do cross the path of the Earth. But the good news is space is pretty big, and if they haven't hit us now, it's unlikely they will. And there's millions of objects in the solar system like this. And comets are hard to find because even though they're mostly made of ice, the surface is coated in like a layer of space dust. And so you only really start to see them when they get close enough to the sun that the outer layers start to melt and they produce those tails that you get to see. So it's not entirely unreasonable that we might not spot a comet like this until we had only like 6 months notice. So I'd say it's very unlikely it would be discovered like it was in this movie, but it does happen. There are people who just look at the thing is because there's so much sky to look at. There are people who just look and by chance see something, but it's very rare someone would actually just be doing what she is doing scientifically in this movie and come across a comet. But I'd say, I mean, when it comes to the science, let's take the first scene. She's in this telescope. It's the Subaru telescope. Here was the first thing that sort of instantly set off my. I mean, I'm sure when a doctor watches ER, they have these moments. But for me, here we have an astronomer in a telescope at night with the lights on. Like using a telescope with the lights on is like trying to collect rain under the ocean. You do astronomy at night because it's dark. Okay. And of course, here's a perfect example of what science consulting is like. They need the lights on to make a scene that you can recognize. In reality, the person would be hidden away in like a dark little room somewhere. So they didn't do that. So there's a lot of things they get right. But that was one of the first things that was like, that's. So
you guys work in the dark when you're inside the telescope? Like all the interior lights are off as well?
You know when they did like there's like a shot down from the telescope panning and there's like a glass screen and some people behind it. That's where you'd actually be sitting. You'd be sitting in a control room with tons of stuff to keep all the light away from the telescope. You don't actually sit in the telescope or next to the telescope because even the light from a tiniest lamp is going to ruin your observations. Like you want pure darkness in that. That's why you have a dome. It's all there to protect you. So there's a perfect example of someone doing something because it needs to look a certain way on screen versus what you'd actually do.
Right on. Real quick, Gasso, patron of the podcast, $15 for the science. Thank you so much, man. That is super generous. Really appreciate that. There was a question back here. I think it was Dork Knight. He said, what is space dust? So you mentioned something interesting. I didn't know. You just taught me something. So comets only begin to form their tails when they get close enough to the sun to melt their exterior, I guess it's ice and water, water. I didn't know that. I thought they just like kind of carry their tails everywhere they want because of the makeup of what they are. But can you elaborate a little bit about what space dust is and how that all happens? So
comets are like dirty snowballs in space. They're made of ice and dust. But when I use that word as a scientist, I mean it. I don't mean like the dry lint that you get back home. What I mean by dust, most of the universe is made of just hydrogen and helium, like an overwhelming majority. So astronomers use the word like metals and dust to refer to pretty much everything else that isn't just hydrogen and helium. Right. So it's mostly tiny grains of silicate like sand. If you wanted to recreate a comet, it's ice and sand and a bit of dirt. And so they're actually sort of charcoal colored on the outside. And they're surrounded by an atmosphere called a coma. And as it gets close to the sun, more and more of the gases start to evaporate. The atmosphere gets thicker. And then the solar wind pushes on that atmosphere and blows it off into the distance and actually creates two tails, a dust tail and a plasma tail. And that's something I love that they got right in this, was when you see the comet later on, it's got not just one tail, but two tails. So one tail from the ices and the gases, because they're very light and easy to push, and another tail that sort of curves around because it's made of dust. Even though like Star Trek DS9 is one of my favorite shows, it commits a cardinal sin in the credits when it has a comet creeping along, leaving a tail behind it like a snail. It's not how it works. The tail of the comet is always pointed away from the sun, because the sun is the thing doing the pushing on the tail.
Oh, so it's not the actual momentum of the comet. Oh, wow.
You can't use the tail to figure out where it's going. The tail just tells you what direction the sun is in.
Bro, you just blew my mind.
It's a good one. It's a good one.
That's awesome.
And of course, DS9, that's where I first saw it. And of course, when I found out that as an adult, I was like, oh, they got it wrong. It's like, I love that show. Don't do that.
Right on. Ricky, did you have any questions about this opening scene where they're kind of discovering the comet?
Like you talk about, that there's been close calls with objects that do come by. One thing too, like I remember always kind of hearing growing up, I don't know if it's changed today, but like, isn't it true? Like less than 10% of the sky is actually like watched by like all the combined telescopes.
This is really good. I'm glad you brought that up because that was true. I remember that statistic. We're so much better at it now than we were because we realized the potential threat of these kind of things. Because when it comes to protecting yourself from comets and asteroids, so asteroids are made of like rock and metals, comets are ice and dust. It's all about how much time you have to deal with it. The more time you have, the better you can do. So we're actually building a mission called DART, which is a mission we're going to have like in the box ready to go to send out if we do detect something like this. Because trying to stop a comet close to the Earth with a nuclear device is like trying to stop a freight train with a BB gun. But one shot from the BB gun, if you have enough time, can create a big enough cumulative difference that you can actually make this difference. So now we actually have whole missions that just scour the sky for anything dangerous. But here's the good news. There are millions of things out there that could hit us like this. But our solar system has been around for like 4.5 billion years. And the good news is most of the stuff that, if it was going to hit us, it probably would have done it already. So that doesn't mean we don't have to keep watching and be ready for this. It just means that thankfully, although we don't know everything that's out there, we're getting better and better at finding out what could be dangerous.
Can you be more specific about how they find these things? Is there like a certain wavelength that we look through with the telescope, or is it just straight up looking at the light coming off of the reflection and taking a picture of it?
Yeah, so I mean, nothing in the solar system apart from the sun makes light that we can see. Everything you see, like when you see the moon, you're just seeing reflected sunlight. When you're seeing Mars, you're seeing reflected sunlight. So it's the exact same for comets and asteroids. The way they do it, she actually did I liked what they did with the screen. You know, when they had the screen up and she had like the pictures going across.
Yeah.
Their interface was great. That's actually an interface called DS9, named after the picture. So I really appreciated that detail, right? Because it wasn't just a made-up GUI. That's what these things look like.
That's cool.
And what she did, when she pressed the thing and just got each day's image, that's not how we do it. What we do is we load up 2 images from different days and we look for things that move between them, because the human brain and even the algorithms are really good at spotting things that change. So when she does the flash, that is actually much more like how we do this. So we have algorithms that scan over these data. We have humans that scan over these data. We do use the free labor of PhD students quite a bit for these kind of things. So I really appreciated those little details, right? They got that right. I loved seeing DS9. There's also the laser that comes out the telescope, the orange laser. That's great. That's actually a system we use to try and mitigate the effects of the atmosphere that we have when looking at the sky. So that was a good detail. I think they actually did a pretty good job with a lot of that.
Right on. My next question. So there was something that they said when they were sitting in front of the whiteboard and they were kind of discussing the comet and its trajectory and stuff. He said, let's go back to the first principle of Carl Sagan. Can you kind of describe that for those of us who don't know what that is? What is he talking about when he says that?
Gotcha. You mixed it a little. He says, what would Carl Sagan do? Because Carl Sagan is just this legendary astronomy scientist and communicator. Like his original Cosmos series still resonates with people today. But what he means is, let's go back to first principles. He actually does the kind of calculations you probably would have done 100 years ago with this kind of thing. So here's what he did wasn't wrong. You would use Gauss's method, but what would you do today? You just plug it into a computer program and let it tell you the answer, right? We've advanced now to the point where people wouldn't actually be doing this themselves. So what he did was right. It's just not what you would actually do. And if I was doing that calculation on the board and I got, it's going to hit the Earth, I'd been like, my God, my math must be awful. You wouldn't trust it until you put it through a computer and you contact the people whose job it is to do that. And that's one thing I did really appreciate. They kept going on about, peer review, and they kept talking about other people confirming the data, because science has to be repeatable and confirmable. So I really appreciated those kind of nods. But yeah, you could do it the way he did it. You just wouldn't trust it, even if it said that.
I kind of saw that as like, because he had a bunch of grad students with him. I saw that as more of like a teachable moment for him. Like he was using that as a way of like teaching them that first principle and how it used. But it went way over my head. I was like, I don't know who Carl Sagan is, and I don't know what the first principle is. But they didn't take time to explain it, so I was hoping you'd be able to.
Going back to first principles just means like going back to basics, like starting from scratch. Let's do this the old-fashioned way. Let's have some fun with it. So that's good. I actually thought, he did a pretty good job with that sort of representation. I mean, that was one of the biggest flaws in this movie, is that it depicts Leonardo DiCaprio in a relationship with women who are over the age of 25. But apart from that, I think they actually did a really good job of, capturing a lot of the idiosyncrasies of scientists and depicting them as real people, with flaws and other things like that. So I thought that was good.
He became like a ladies' man in this movie. He got some fame to him. He cleaned up his beard a little bit, and he was I think they named him the sexiest astronomer on the planet or something like that.
I don't have to worry about.
So that's not accurate. You guys are not just like ultra sexy on the
I am certainly not the sexiest astronomer on the planet. I can guarantee that. It's been 20 years since I was even remotely interesting, so that's not a problem.
Right on.
So there's no calendar.
No, it would be that could be a green calendar, right?
I was gonna say, I do have like a follow-up with my question about watching, the sky. I'll just use the reference of, NASA's been around for like just a little over 6 decades, and like in that time period, how many close calls have there been potentially? I guess.
Good. So I'll get sciencey on you to start because it all depends how you define these things, right? So here we're talking about like a 10-kilometer comet, which is normal-ish size for a big comet. We worry about everything that's over about 150 meters. Like a 50-meter rock causes local damage.
Okay.
If you ever want to see it, if you're based in Vegas, go to Meteor Crater. It's only a few hours away from you in Arizona.
Mm-hmm.
You'll see this kilometer-wide hole in the earth. That was caused by only a 50-meter rock. 150 meters causes some pretty serious damage over a decent area. And then kilometer size can be really, really deadly. So we've seen, near misses and close calls, but not with anything that would have caused serious global damage or even massive regional damage. We've seen close calls with things that are pretty small. Because when you see a shooting star, even though it's pretty bright, something that causes that is only about the size of a grain of sand. All that light is coming from this tiny thing. And there's just so much energy in it because it's moving so fast, right? It's moving between 10 and 70 kilometers per second, right? This stuff is going super fast. So even small things like that cause a big bright light. Something has to get up to the size of maybe like a small house before anything would actually land on the ground like that.
Okay.
It would just burn up in the atmosphere. But when you get to the big stuff, we've never seen any near miss from something that would truly be catastrophic yet. Anyway,
well, since I'm not familiar with metric, I looked that up. So 50 meters is 165 feet, and 150 meters is 500 feet. So
that's true. I've been living in America, so I was born in the States. I've been back here for 8 years now, and I've just about gotten used to thinking in Fahrenheit.
Mm-hmm.
And I don't convert my money back into pounds anymore. But you're not going to get me working in feet. I can't.
No problem. I'm just thinking of everybody in the chat because I'm like, well, how big is 50 meters?
Yes.
It's funny because I'm homeschooling my kid and we do math class, and he's at the point now where they're kind of making the distinction between what the metric system is versus the imperial system. And I look at this and I'm like, why the hell do we still use the imperial system?
I feel so bad. We invent it, we give it to you, and then we abandon you and switch to like SI. It's kind of hard,
the metric system is so much easier to understand. So there's that like viral video that it was probably, it must have been 10 years ago, but it was in Russia where some kind of something came flying through the atmosphere and it lit up the entire area.
The tower Chelyabinsk.
Yeah, so you're familiar with that.
Yeah.
About
it's
what
an
size
airburst event because it burst in the air.
Yeah, about what size was that? Would you say?
I would have to double check that. It's been long enough that my memories. But you're going to be talking maybe like, I'm going to guess like 10 meters, but now you've put me on the spot. I have to actually, like as a scientist, I cannot let this go.
No, that's fine.
I don't know how to stop Chelyabinsk. But...
So during this part of the movie, they're kind of discussing, what its trajectory is, what it is, how big it is. That was the other thing I had a question about because we're looking at something that's millions upon millions of miles away. How do we determine the size? Are we taking it in comparison to something else that we actually know the size of, and then we just calculate the math of like, okay, so if this is that size and it's this far away and this is that far away, like how do we determine all those numbers?
This is good. Yeah. So it's great if you have something to compare it to, but normally these things are just floating around sort of in space by themselves. What you kind of do is, if something is far away, it looks really small. Mm-hmm. And if something is close, it looks really big. Yeah. You kind of watch it over time and see if it's getting bigger really quickly, then it's pretty close to you. Okay. If it's getting bigger really slowly, it's like super far away. And the more you watch it, the better. And I really love how they start off by saying, oh, it's somewhere between 5 and 10 kilometers. And then they say, oh, it's around 8. And later it changes to 9 mm-hmm. because that's how science works, right? It's never true. It's never just true or false. You keep updating what you know with new data. And I really appreciated all those little details of like, it starts with a big error and it gets more and more accurate the more you watch it. That was actually pretty good.
Right on. Did you find out how big that was?
No, I got size of Chelyabinsk, and I had to try this. Here we go. Size. They call it a meteor. I can tell you the difference between that.
Oh yeah, please do.
And that's a major explosion. About 17 meters.
Okay.
There we go. So yeah, that's on the just around the size where it might just about get to the ground. They actually do use the term. So we said asteroid. That's like rock and iron metals, right? Comet, which is like ice and dust. The Mark Rylance character actually gets this right. He says if we can break it up, then the meteors will be much smaller. And so we actually have words for these things. If you have a small chunk of something in space that's not a comet or asteroid, we call it a meteoroid.
Yeah.
When you see it in the atmosphere, like when it's burning up, we call it a meteor. And if something lands on the ground from that, we call it a meteorite. So it's a specific term. So I love that detail again. He's like, yeah, when we break apart the comet, the meteoroids would be much smaller. I'm like, yep. Good job, science consultant. Well done.
Right on. Cool. Matt Vader in the chat right now, being our young Jamie, like the Joe Rogan podcast, said the asteroid. I'm assuming he took this and just like clicked and pasted, but it says the asteroid was about 17 meters in diameter and weighed approximately 10,000 metric tons. That's freaking huge. It says Peter Brown, a physics professor at the University of Western
So my 10-meter
Ontario.
guess was pretty good, right? I mean, within science, they say orders of magnitude, right? And that means, is it 10 or 100 or 1,000? So 10 to 17, I'm going to call that a win. And it's good to see Vader's around. I loved hearing he was a Red Dwarf fan in one of your podcasts. Being a British fan, I couldn't help but appreciate the love he was showing for that show. So thank you, Matt.
Right on. Yeah, today is his day off, so he might be able to pop in a little bit later when we're getting closer to the end of the podcast. He might be able to hop in and say hi to you.
I'm pretty sure he didn't like me at the convention, but that's okay.
I doubt that very much. He's a big teddy bear. All right, let's see. Okay, so the next thing that happens, once they do determine it's headed towards Earth, we have this amount of time, they start going through what they call the proper channels within the government to try and bring attention to this thing. Have you ever had to deal with that? Is that something that they teach scientists? Like, okay, if you do discover this, call this number. Is there a big red phone in your laboratory somewhere where you're like, that's the oh shit phone I have to call?
Well, I actually really like that. Like, I love the scene at the beginning where she's just like looking at the screen. She's like, because you don't know what it is, right? It takes time to figure out what something is. So really, you're like, oh, that's kind of odd. The first thing you do is probably just like, hey, call some of your buddies who you know work in this area. You wouldn't instantly go, oh my God, I know exactly what it is. You'd have like 20 people check it and confirm it. And so that's the other thing about when they talk about containment of information. Astronomers would have passed it around every country already just to check themselves and check.
Yeah.
I spend 90% of my career trying to prove myself wrong. Because if I don't, someone else is going to do it, and I'm going to look like an idiot. So as a result, you'd just be like, "Oh, that's kind of curious. Let's think about it." So there wouldn't be the need for that phone because you wouldn't know quick enough to make that kind of call. I love that they had the Planetary Defense Coordination Office, because that's a real thing, as they say.
I was going to say that seemed like they were actually taking a nod at the real world.
You can see their motto at the bottom. It's if you translate it from Latin, it's the translation is "Here to save the day." So I thought that was a really good. A really good little thing like that.
That's great.
So
I love nerds.
We also know where comets come from. So comets, there's two. This is another thing they got really right. Where comets come from either the Kuiper belt, which is a collection of objects in the disk of the solar system. It's what we used to think that Pluto was like an ugly duckling of a planet, but then it turned out to be like the swan of a Kuiper belt object. Or they come from the Oort cloud, like this says, which is almost like a light year out from it's like a swarm of comets around the solar system. So Kuiper belt objects come in from the disk of the solar system. We call those short period comets. Comets like this come in from the Oort cloud, and it's long period comets. I love they said long period comet. They're using the correct language. Does come from the Oort. No, who else knows what the Oort cloud is, right? I love that as a
That's
detail.
the first time I'm hearing of it. That's really cool. Right on. So this ring of debris, I guess, in the outer solar system, is it farther away than Pluto, or is Pluto kind of like in the middle?
It ranges between. So we use the right tool for this job is an AU, an astronomical unit. We are 1 AU from the sun.
Okay.
Jupiter is like 5.2. Pluto much further out. That's like getting out to 40 AU, and the Kuiper belt is like 30 to 50 AU out there. So it's a whole collection of comets, asteroids, dwarf planets like Pluto.
Okay, so like the Earth is 1 AU from the sun.
93
so they're using
million miles, or 1.15 times 10 to the 15 meters.
I was going to say, so 93 million miles is 1 unit.
Yep.
Astronomical unit.
Mars is 1.5, Jupiter is 5.2, Venus is 8.3, Mercury is 0. I'm just showing off now.
No, it's good, man. That's what we're here for.
I teach this in my class, so I do it every year, and it's all just stuck in there.
That's great, man. That's great. I think it's important to get this kind of stuff out there, and if there's somebody watching now or in the future, they watch this episode and they're like, man, that's fascinating, and they go and they educate themselves and they move on to become an astrophysicist, I think that would be awesome. If somebody comes to me in like 15 years and said, I watched your podcast with Dr. Targett and that made me become an astrophysicist, I'm going to lose my mind.
I use that at all the we go to the Star Trek conventions, right? And they're like, I'm just the classic story of kid who watched too much Star Trek who became scientist. They're sick of hearing it by now, but it's true. Like that's what got me into it.
This is funny. Dork Knight says, this movie was depressing because I felt like that's what would really happen. Like, so in today's world, and this we can kind of touch on the politics of today's United States climate and stuff like that. But do you feel like the message of a bunch of astronomers going to the government and saying, "Hey, we have a serious issue. This is going to happen. We need to do something about it." Do you feel like the movie depict the relationship with like politicians and actual scientists realistically? How do you feel like that would kind of happen in the real world?
Gotcha. No, I think the office of the president would be far more receptive to what, especially the head of these defense organizations would say, and that's we have actually whole plans and contingencies already laid out because this is something we are concerned about. So the president would already know that, and it's not like they have to figure out what to do on the fly. They'd be like, "Hey, we want to implement Plan 3 for this thing," or whatever the idea is. So I think they would take it more seriously. For me, the real fascinating part was watching the relationship between the scientists and the media organizations, because dealing with the media is, I mean, I've met some amazing journalists. Like I've done things which have been in the press, and sometimes when I've read what the journalist has written about what I did, it was better than what I wrote. I'm like, yes, that is a good job. There are people who were spectacular at this, but I'll tell you my media story. Like there's a couple of mistakes you can make. If you go on, I've been on the radio, for example, and the presenters usually want to sound like they know what they're talking about. So they say, "Hey, can you write us a little description of what it is you're going to be doing?" And you say, "Sure." And you write them a really good description. And then you show up at the radio booth and you're recording it. And they say, "Welcome, Dr. Targett. Now we hear that." And they read the entire description that you gave them. And like, "Tell us more about that." And I'm like, "Well, I can't, because you literally said everything I was just about to say. So now I'm going to say it in a slightly different way and sound like an idiot."
Yeah.
Like that. And then the other thing that will happen is that I love the little snippets they had in there, like, "Oh, are aliens real? This is something you threw at me at the Star Trek convention."
It's one of the questions that I asked you at the Star Trek convention.
And there's the best moment in the film for me, because he starts to give the scientific answer, right? He starts saying, "Well, with 100 billion stars and 100 billion galaxies," and he goes like, "No, whatever. No, yes, sure. Yeah, whatever. They're real." Because
there's absolutely
that's how you have to kind of communicate in these kind of environments. But I remember like the very first radio interview I did, it was about a Scottish astronaut going up to the International Space Station. And we start the interview and they ask me a few simple questions. And it's kind of dull, and you can tell they're not thrilled with it, because I'm just talking about a guy going to space. And then they ask, "Oh, has anyone ever had sex in space?" And I'm like, I don't know. Like that's because they're trying to make it interesting and exciting. And so
I'd probably say, like, statistically, probably yes.
The thing is that, and then the broadcast time is coming up. I tell my parents to listen to this interview, and on comes a presentation, and they've dropped me for a whole segment on which British biscuits are best to dunk in tea. Rather than talk about, because what I said wasn't interesting enough, right? So there is that real pressure to condense. People want things in science to be, this is true or false. I love that with they're like, there's 100% chance, and they're like, "Oh no, there's like a 99.76% chance of this." It's like, "Oh well, that's not 100," and it's like, to me, it's good enough, right? They've given you the uncertainty, they've given you what it is, but it's so hard to have those conversations because and I love the way when they start to talk, they start to tell you what seems like too much information, like, "Oh, she was looking at this for this reason and doing this kind of," because that's how we communicate with each other.
Right.
Like the way they're talking is how colleagues would talk to each other, but it's not how you should talk to media or the politicians. You have to compromise a little bit, because what you say is meaningless unless the information gets across.
Yeah, 100%. Yeah, that I think the show that they were on was called The Daily Rip or something like that.
Yeah.
And it was basically, I mean, it was like I don't even know what to compare it to. It's like a, I don't know, Good Morning America or something like that, or basically maybe a little bit more edgier than that, but they kind of took the wind out of their sails as far as like how important this whole situation was. And then with social media the way it is today, and I know we've talked about this before. You said you don't have Twitter because you just can't stand it. I'm exactly the same way. I got rid of mine. I gave it to my colleague. I was like, "You do it. I'm not doing it." How do you feel like news like this, if it were to happen in the real world, do you think people would completely panic? I always think, like, in my head, the way I am, I'm very cynical about humanity. I would be like, I probably would keep this under wraps as long as possible, because the minute you say something, the whole freaking world is going to go straight to the gutter. There's going to be riots. There's going to be the shelves are going to be empty. There's all the preppers are going to bury themselves in holes. Like, I don't think it would go well putting this information out there. I don't know. How do you feel about that?
I think that, I haven't seen the defense plans that they have for these kind of scenarios, but I'm willing to bet a lot of it is media strategy. Mm-hmm. And that's one of the reasons you want to be able to say, "Hey, we have this DART mission. We already have the mission in place. We know how to do this. it's that ability that you'd want to get across, because there would be, the reactions would be unpredictable to see how it goes. So yeah, it can be messy. And that's not my area of expertise, right? That's why I stay off Twitter. Like, that's just
you'd be the guy where they look at like he needs social media training.
I know, like, at the end of your podcast, they were like, where can we find you? And I'm like, don't find me. Like, I'll find you. Like, that's fine. Like, just leave me alone. Like, that's it.
Ricky, you got any other questions, bud?
Well, I was gonna say, yeah. I mean, I have to imagine, like, if something like that came out, right, and they announced that meteors headed towards Earth. Like, think of the chaos we experienced in 2020 with panic buying. I mean, can you only imagine what would happen? You know, like
no
with
toilet
that type
paper,
of stuff too.
everything's crazy.
Yeah, toilet paper.
Oh my god. Yeah. That's why I invested in bidets.
It still makes me laugh when I hear that. Like, there's a respiratory disease going around. Buy all the toilet paper. Like, what?
That's one of the things I loved about this movie, was just showing, like, humans being humans with all our idiosyncrasies while this crisis is going on. Like we talked at the beginning, like one of my favorite characters was like the general who sold them the water and the snacks, who was played by that guy from CSI, like that. Yeah. And it's just a wonderful little moment of, the world is about to end, but people are still doing the things that make them people. I thought that was a lovely little sort of satire. And I love the way that I love the way Jennifer Lawrence couldn't give it up throughout the whole movie, right? She couldn't let go of the fact that he'd done this. Because this is how like a scientist mind works, right? When you ask me how big is the Chelyabinsk comet, it's going to bug the hell out of me until I look it up.
Until you find it out, yeah.
She just can't accept that someone, she's looking for a rational reason why someone would do something irrational.
Yeah.
And that's what it's like to be a scientist. You're like, I can understand the natural world because it obeys the physical laws. But people, they're tough, right? They're messy. They're harder to understand.
So for context, for people who might not have seen that moment in the movie, so Jennifer Lawrence plays this character. They're at the White House. They're waiting outside the Oval Office to be able to meet the president, and they're out there for hours. And this 3- or 4-star general comes up, and he brings them snacks. And he's like, hey, guys, they charge an arm and a leg for this. If you just want to chip in like $10 a piece, that should cover the bill. And it's like Cheez-Its and water. Like, it's nothing. And then like 10 minutes later, Jennifer Lawrence goes and she walks into like this little kitchenette area, and there's Cheez-Its and water just for free laying on the countertop, and it gets into her head like he conned us out of like $40 just for snacks. Like, it's a reoccurring joke throughout the entire movie. She goes on and on like, I don't understand why he would do that. He's a 4-star general, this and that.
And the world is ending, and he's doing this.
Yeah, and the world's ending, and he's conning people out of $40.
I love the way he's like, hey, Michigan State Spartans, right? Like that sort of classic. As an astronomer, like I watch the World Cup and stuff, but I'm not that big. Whereas he's the pitching a military guy, he's probably more into sports, so he's trying to start up a conversation, but showing you that difference between. I love that. There's so many great details in this film.
There was a moment once they did get into the Oval Office, and they realized that these people are state university, and they kind of like chuckle at that, like, oh my gosh, we got these guys, like, let's get some Ivy Leaguers, let's call some like NASA people. How realistic is that? Do people look at different universities different like that, or like, oh, you're just from freaking Chicago or whatever it is? Like,
it's funny. It's not so much they look down. It's more that so academia is incredibly competitive. Like, getting a PhD is a significant achievement, but only 1 in 10 astronomers that get PhDs get tenure-track jobs, because there's no private sector. I mean, there's a little bit of private sector astronomy nowadays, but there's not too much, right? So if you can get a tenured position, then that's the goal you can do. So. Well, the funny thing about that was I remember I was talking to a friend who was still in that frenzied state of trying to get a job. And he's looking around and he's like, oh, should I keep going for the pure research, like Ivy League type stuff? Or should I do what Tom's done, and go to a state university or something like that? And so we're talking on Skype, and he's like, oh, so Tom, what's it like to have left academia? I'm like, oh, that's harsh. That's so harsh. Because I don't blame him. He wasn't being mean in the slightest, right? He's coming from a place of where I was, like, it's research or bust, and then it's a different step, right? I chose to become more of a teacher than a researcher.
All right, so the chat is revolting right now. You mentioned the biscuits a while ago, and people are obsessing about what's the deal with the biscuits. What was this story? So you're gonna have to elaborate, or I think the chat might revolt on us. So what was the story with the interview about the biscuits? And
so I was sitting there with all my friends in my office, waiting to hear my very first media appearance. And my proud parents were, listening to the radio, waiting to hear my voice on like BBC national radio. And then along comes the hour when my thing is supposed to start. And Welcome to the BBC. We'd love to tell you today about a fascinating story where we've done an investigation into, of all the biscuits in Britain, which are the best to dunk in tea. And I'm sitting there like, what? This is my moment. Like, this was everything. And everything's missing. And I'm like, oh no. So the sad thing is, I can't even tell you the answer to the question, which biscuits are best to dunk in tea, because I was too distraught to actually continue listening to that broadcast. So I apologize that I don't have that answer for you.
We'll have to. It's got to be out there on the internet somewhere.
That was funny.
This is a great question from my lovely wife. She says, "What is your least favorite part of the movie? Was there a moment in the movie that kind of was like, oh, that's so dumb?"
I guess for me, it's the science stuff that it's hard to turn your brain off for. Mm-hmm. So it's noticing those details. They do such a good job of the small stuff. But this is jumping to the end of the movie when you've got the comet approaching. Yeah, the thing is, this comet is traveling. Let's just make up a number. The average 46 kilometers per second, right? Mm-hmm. Now, space is not actually that far above your head. Space is only about 100 miles above your head. So the time it would take a comet to travel from the edge of space to hit the surface of our planet is a fraction of a second, because it's going at thousands of meters per second, and it's only got to cover 100-mile distance.
Right.
Yet in the show, there's like a 5-minute montage of this thing slowly lumbering in and everyone reacting and things like this, and it's just like, no, that's not. You were so close to greatness, and then you
be dramatic,
like that, and it's things like that I can't help but be like, no, that's I'm trying to lose myself in the moment, but I can't let it go. Like it's like the water and the crackers, I can't let it go.
$5 from Backyard TARDIS, another big Doctor Who fan. He says, once again, upstaged by biscuits.
I mean, to be fair, biscuits are pretty interesting. I only have a limited amount of interest. Biscuits are universal, right?
Everybody's obsessed with biscuits. Meanwhile, we're talking about real science here, people.
You call them like cookies, right? But they're not soft. They're hard, right? This is the classic American versus British biscuit versus cookie. So in my world,
where I live, you don't.
I don't mean like biscuits and gravy, right?
Gravy.
No. It's the thing. So if it's a soft cookie, I call it a cookie. If it's a hard cookie, I call it a biscuit. Right? That's the way it goes.
All right, let's get back on. Enough with the biscuits. My next question. So we kind of touched on this a little bit. You mentioned throwing a nuke at a meteor is like throwing a BB at a freight train. Movies almost always depict the first course of action for governments is, hey, we're going to nuke the crap out of it and hope that it goes away. Like, would that in any realm of the possibility work at all, or is that just a nonsensical Hollywood thing?
It's a bad option. It's an option, but it's an option. Let me tell you why. This is like harking back to like Armageddon and Deep Impact, right, where they fire Bruce Willis directly at an asteroid.
Right.
So it's the thing about nukes in space is they're not actually anywhere near as effective as you might think they would be. Because when a nuclear device goes off on the Earth, a lot of the actual damage is caused by the shock wave of the air expanding out. In space, there is no air. So you set off a nuke in space, you release a whole bunch of energy, but you don't get that sort of pushing effect that you would want. So if you were to use nukes, there's a couple of things. You'd probably actually want to send a few at a time, and you keep poking one side of it. And what you'd actually hope was the first nuke might create a little bit of a crater on the surface of the comet, a little dent. And then the second nuke, you detonate in the crater, and the crater would act as like an engine, like the little dumbbells you see at the end of the rocket to push it aside. So nuking things in space, nowhere near as effective as you might think it is. They're much more effective here on the Earth. Okay. There's two things there's three ideas that we might deploy. So the NASA DART mission is like the BB gun example. It's basically spot it as early as you can, fly out to it as quick as you can, and just give it a nudge. And that's all you need to do, because that tiny change in path over the millions of miles it's going to travel cumulatively becomes significant. Mm-hmm. Another idea is something called a gravity tug, which is basically you go and park a heavy object next to the asteroid, and you use the gravity of the heavy object you parked there to slowly pull the asteroid. Now, of course, if you left it alone, the two things would just go together. So you have a little engine on your heavy thing to keep it separated from the asteroid, and you're doing the same thing. You're just trying to deflect the path of it. The other thing you could do is maybe set up a solar sail on the surface of the comet.
Okay.
Same physics, tiny deflection. That's why when they say we're going to sit and we're going to think about it, that's when the astronomers are screaming. It's like, no, like you need to act early and quickly, and the closer it gets, you have fewer and fewer options. You certainly wouldn't send Ron Perlman up in a recommissioned space. That was the other thing. I was watching that, and you're like, okay, you'd never launch all those ships at the same time because you'd see what happened with the beads. They probably bump into each other. You certainly wouldn't send people, even though, of course, you wouldn't need to.
Yeah.
And space shuttles can't go much beyond the orbit of the Earth. They'd be absolutely useless. You'd need to send. Even our ICBMs are designed to travel around the planet and hit things on the surface. They're not designed to go into deep space and hit comets and asteroids.
Yeah.
So that was the real sort of, okay, I get what you're doing in the story, but that's not what you would want to do in any way.
Yeah, I always wondered that, like, these instruments that we have, vast majority of them are meant to go from point A to point B on Earth.
Mm-hmm.
Like, what kind of prep time would they need in order to build these specific devices to go to an area? We have to map out, we're going to go from the Earth, which is moving, to a comet, which is also moving, and we have to hit it accurately and then explode some kind of an ordnance on it to try and move it, if that would work, or even if you wanted to attach like some kind of a solar sail to it. Like, that's really complicated stuff. Like, how much prep time would you need? Would you be able to do it in 6 months, like the movie says?
Yeah, this is why we're building the DART mission ahead of time, because we actually sent, I think it's called Neowise, the mission we actually sent to land on a comet, and it took a decade of development to build this thing. It's hard to actually bullseye these things in space because space is so huge and the velocities involved are so colossal.
Right.
And all we were trying to do was land on it, and we even kind of messed that up a little bit. We ended up landing in like a tiny crevice, and we couldn't get any sunlight on the solar panels, and it sent back a few pictures and then died. Right, and that was a decade of work.
Right.
So yeah, these things are very difficult, and our technology, all we've done is send things into orbit and visit the moon. Right, we're pretty domestic in space terms.
Oh, for sure.
Yeah.
Yeah.
Of course, that's why near the end of the movie they go crazy with the the mission to another world.
Yeah, that goes full science fiction.
Yeah. We can do that at the end, but yeah, this is not an easy thing. That's why it's about being prepared, because one of the most exciting things in astronomy right now is the launch of that James Webb Space Telescope.
Mm-hmm.
That's been in development for over 2 decades. Like, they were talking about that when I was in college 20 years ago, and it's an amazing mission, but it's taken all of this time and testing. And I think the movie The Martian did a really great job with that. They try and rush it, and it doesn't work because these things are hard. So yeah, you do not want to be unprepared. Firing Bruce Willis is the last resort. Like, it's not your first option.
That's the Hail Mary. Right on. Ricky, you got anything else for him, bud?
Yeah, no, not really on that. That's just that's just a lot to comprehend.
I kind of dumped a whole bunch on you there, right?
No, I always wonder how likely it is that we could even do anything about this. Like, okay, we got 6 months, because you said they are difficult to see unless they get close enough, and you're like, okay, it's already here. What do we do? Well, we have this thing prepared, but it might not work.
Yep. Yeah, it's all about preparation, and that's why that's why we study these things. This is coming back to Ricky's question about studying these things in space. It's all about preempting it. You want years of knowledge of these things in the future, and that's why we devote so much time to these huge databases of all these objects that we know about, and we track them, we look for changes, we check up on them, we do all of this kind of stuff, so we're not caught flat-footed without much time to do it.
Our chat, I guess it seemed.
I was going to say,
it seems like. Go ahead.
Sorry, Ricky. I just want to say this real quick. Our chat has gone full Jesse Pinkman over here. They're like, "Yeah, science, bitch." They're talking about freaking space horses and stuff. These guys have gone off the rail. Go ahead, Ricky.
Well, it does seem like, though, they would have multiple darts, like you said. They wouldn't shoot them all off at the same time, but it almost seems like they would have they'd launch a second one after the first one, just to be on the safe side.
And like when they abort the mission and they have people bailing out, that's not how we abort space missions either, right? Coming down on parachutes, but it's the classic case of, I really appreciate the effort that a lot of productions go to try and show you some of the science behind it, but they always have to have entertainment come first. I don't blame them for that, right? But you're just, as a scientist, you're just sitting there going like, oh God, that's not how it works. But it was a good scene. It's not a good scientific representation.
Right. There was 2 things that you mentioned. The first thing you said, we have to launch a heavy thing at it and kind of do like a gravity pull. How heavy would that object have to be if we have a 9-kilometer sized meteor coming towards the Earth?
So this is cumulative. So the good thing about that is it's all about small effects over time. It's useless if it's only a few months away, right? Because you can't launch anything heavy enough to make a big difference. But if you can get to this thing early, every single moment that goes by, you're deflecting its path a tiny amount, and you can
Right.
do it like that. So it's all about quick action, early detection, intervention, not nuke it, from when it's close to you. That's like the worst, not the worst option, but that would be the real emergency last resort kind of thing.
Yeah, last ditch ever. Okay, so are we talking like just hunks of iron? What is it that we would send, like tungsten? I don't know. What are we going to send to space to kind of use
tricky,
as
right?
like a
Because
heavy
like
object?
every kilogram of material you launch into space costs about $25,000 to launch, because it's not easy. We've got to fight the gravity we have around the Earth to get up into space. So yeah, and anything you could easily launch that's stable. Iron is pretty cheap, and pretty dense. That's not too bad a thing. Anything with high density, like lead, would be a good choice.
Okay.
It's just a pain to get up there. That's when we'd love to go into the sci-fi territory of like space elevators and crazy things like that. But right now,
those things.
Rockets are basically a mostly controlled explosion that you're riding up. It's very messy, right? So this is even gravity tugs are kind of science fiction, right? The DART mission is the best thing we have in terms of this, and it's pretty simple.
Right. I'm sorry. I'm just laughing at our chat. They're just going off the rails right now. They're talking all kinds of stuff. He's like, wait, I thought, Backyard TARDIS, wait, I thought the newly formed Space Force was building a Death Star. Isn't that problem solved? Just laser it like Alderaan. Yeah, I hope they have a plan in place. I know with characters like Elon Musk and Jeff Bezos shooting freaking their dongs into space every day, the technology is there. I'm really hoping that we can have something in place. I wonder if, hidden deep down in Area 51 somewhere, we have some kind of laser weapon or something like that.
If you're looking for science advice from Star Wars, you're looking in all the wrong places.
Yeah.
Yeah,
was that
can't
an
we just
Alderaan
fire a
joke?
Bezos
That was an
dong at it?
Alderaan joke. I'm glad you got it. There you go.
All right. Playdo23, Patreon of the podcast. Hello, how are you doing? It says, Tom, thank you for feeding our nerd brains. What movie and or series makes you geek out over the scientific accuracy? And then she does the live long and prosper. Thank you so much for the $25. Go ahead, take it away, Tom.
I appreciate that. I mean, this is my first internet live stream that I've done, and seeing people donate is just fun, fascinating for me, because it tells me that I'm not doing a horrible job. At least, like, people are kind of interested. So, I don't get any of that money, but I appreciate the thinking that people are interested in that. So yeah, this is great. So Star Trek is what got me into it, because Star Trek, one of the things that's big difference between Star Trek and Star Wars, like the engines on Star Wars exist to get the ships from one place to another. Like the way the engines work on Star Trek are like 90% of whole episodes. So that's why Star Trek was always the big one for me, and that they did such a great job bringing in as much detail as they could and establishing a system that they're pretty consistent with from episodes to the next. I thought that was really good. So Star Trek was huge. The Expanse is another one that I absolutely adore. Like watching like the G-force effects of the combat, or how they maneuver, how they accelerate and slow down. I'd love to talk about The Expanse with you sometime, because that's such a spectacular show in terms of the science. So I love The Expanse and Star Trek, because there's so many details in Star Trek they just kind of throw in there. Like Data will scan the window and they'll say, oh, the transparent aluminum alloy in this window. It's like, yes, it's not glass, because that would be dumb. It would break, right? That. Yeah. Or what about dilithium crystals? They actually tell you how dilithium crystals work. They turn the high energy photons that you get from an antimatter reaction into an electrical current. Now, of course, that's fictitious, but at least they're explaining how you would get the energy released from an antimatter annihilation converted into usable electrical mechanical energy. So there's so many lovely details in that show, and that's why Star Trek has always had that special place in my heart. So I'd certainly say that those are the ones to go through.
On the same rail as Star Trek, it says, how far are we from actual Star Trek spaceships? So
this is great. Sorry, I don't mean to cut you off. Sorry,
no, go ahead. Yeah, take it away, man.
So we actually have a piece of technology from Star Trek that we've made real, and that is the ion drive. So the impulse drive, they call it in Star Trek. But why is that so special? Well, the reason is with rockets, rocket fuel is highly, it's heavy, it's inefficient, and it's ineffective. The way a rocket works is you do a huge burst in a short time, and then you just kind of cruise for a long time. What you want is a propulsion system which doesn't need much physical fuel, but you can use energy as a propellant as best as you can. So an ion drive, you have maybe solar panels, or preferably like a nuclear reactor on your spaceship. You set up an electromagnet, you create an incredibly powerful magnetic field in the drive, and then you just have to throw a tiny amount of like xenon or any kind of gas like that into the drive, and the magnet accelerates it very quickly. And the thing about a drive like that is, because it uses fuel very efficiently, you can just leave that drive on. So it's not like you get a big burst of speed. It's that it cumulatively builds up your speed. And this is how the expanse works. You spend half of your trip pointed in one direction, building up speed. Then you flip your ship around and spend the whole second half of the trip slowing down like that. So that doesn't mean we have the Enterprise, but it means we have like the distant great grandfather of the impulse drive, or the TIE fighter, the twin ion engine.
Exactly. Yeah. When you said ion engines, I'm like, I know where that's from.
Yep.
Excellent.
This is a little dated, so I mean, this is like going back 30 years. I remember when the TIE fighter video game came out, and they had interviewed some scientists about twin ion engines, like if we had anything like that. And they talked about like, yeah, like we can make that, but they're just not powerful enough at that time. And the other issue was the amount of energy. Like it was extremely limited, where it wouldn't be like efficient enough to do anything. Because they also got into like like technically, at least, from what I remember from that article, like I said, 30 years ago, they talked about like, it's easy to go fast in space. It's tough to slow down. Is really the big tricky thing.
Star Wars is a big one because I love Star Wars. And by that, I mean the 6 Star Wars films that exist. But the thing with using an ion drive for something like a TIE fighter. So when you watch the ships fly around in Star Wars, what George Lucas did was basically recreate the motion of Second World War aircraft. So things are moving like they do in an atmosphere. So the thing about like an ion drive, if this is your ship and it's going along, if you turn it sideways and thrust up, because you just sort of do that. So ion engines are what you do want to use in space, but you're talking expanse style movement rather than Star Wars turning and dogfighting. And doesn't mean I don't love Star Wars, right? But it just means you have to take it for what it is. Like you know that Star Wars isn't trying to be.
It's closer, it's closer to fantasy than it is actual science fiction. There's another $5 super chat. It says, okay, this guy's been talking about Spaceballs since we started this live stream. He said, okay, now how long until we have Winnebangos and Mega Maids? I would love to meet Mog.
Spaceballs, I grew up with that film as well, right? It's just, it was so much fun. I love that. And I saw someone else ask about tractor beams.
Yes.
That's a fun idea. That ties into the scientific concept of the graviton, which is the particle physics model of gravity. That's not necessarily a real thing. That's just a model of gravity in a particle physics world. But again, it's fun to be able to try and make these kind of connections. And then with Spaceballs, just obviously it's a silly movie, but there's still some sort of fun stuff in there. In terms of taking the atmosphere away from a planet. Sure, atmospheres are pretty fragile things. You could strip them off planets and do things like that. And the bigger the ship is, the slower it moves and stuff like that. Yep. So that was a fun movie. I still watch that.
You mean speed matters in space?
Yeah, only if it's ludicrous speed. That's the way.
All right. So we kind of talked about like the meteor actually impacts Earth in this movie, Don't Look Up, and kind of things went awry. And it's kind of a lesson for us, like if we're not careful with our planet, there's all kinds of messaging going on in this movie. My question really is like, is there anything that we could do to survive on the planet? If everything failed, all of our mechanisms didn't work, we missed our chance, and it's heading towards us. How far down can we dig? Can we create some kind of subterranean living condition? Is there any possible way for us to move past this, I guess, nuclear winter that would come about?
Gotcha. Well, I'll start off with a more general. This is something I tell my students in class, which is please don't destroy society.
Right.
Because we actually couldn't rebuild a technological civilization on the Earth if we lose what we have. We have mined all of the easily accessible resources on this planet. So now you need technology to get to virgin materials pretty easily. So the problem is if our society collapses and we lose the ability to do that, we couldn't get the materials we need to make the technology we need to mine new materials. So please don't destroy society is my message on that front. Now, bunkers and underground, bunkers and things like this, there are versions of these that existed to survive nuclear exchanges and things like that. But I think with a cataclysmic event like this, there would be those tremors through the Earth, right? There's these different kinds of seismic waves that travel through the crust that could also be truly catastrophic for that. Now they did call it an extinction level event, and that's partially true because it would be the death of probably most complicated life forms on this planet. But it wouldn't be the end of all life. You'd probably have a lot of certainly single-celled organisms, and even some simple creatures could probably survive. Like if Jonah Hill can survive it in the ground, that's something. But so it's not really, even the preppers wouldn't be able to really survive that too well, because it's just we're not talking about like a nuclear winter or, the sort of man-made things. We're talking about something truly catastrophic on a planetary scale. So don't destroy civilization, and please stop asteroid impacts.
Okay. At the very end, spoiler warning for the very, very end of this movie, they do something which honestly I thought was kind of like the coolest part of this movie. Is the super elite rich, of course, they have this spaceship that carries about 2,000 people, and they take it to an area that they call the Goldilocks Zone. A lot of us nerds have heard of this before. It's that perfect ground where another planet that can exist just like Earth. And they take this group of people and they put them in cryosleep, and they go there, they land, they get out, and it's like this wonderful, beautiful, utopian alien world. Is there any reality to that? Where are we with cryosleep? How long does it take to get to the nearest Goldilocks Zone? Is there another planet around us that we could actually get to realistically?
Okay, so the end is pretty much all sci-fi, right? But it doesn't mean there's not some fun stuff to talk about. So every star has what you call the Goldilocks zone. And really, as a scientist, that means not too close to the sun that liquid water would just boil on a planet, and not too far away from a star that liquid water would freeze. So it means, it doesn't mean nice and green grass and things like that, right? It just means not a furnace or not a freezer. So every star has one to some extent. In our solar system, Venus is kind of just on the inner edge. It's far too hot, and Mars is just on the outer edge. So that's got a good sense. Now, the good news is, over the last 10 years, we've been able to demonstrate to a high degree of certainty that planets are pretty much ubiquitous around all stars, as far as we can tell. So if you go back a couple of decades, we only really knew about the planets in our solar system, and now we know about many thousands of planets around other stars. So that's good news, in that almost all stars seem to have planets, and they have so many of them that it's very likely that some of those planets would be in the habitable zone of their star. Now, the problem with space is that it's really, really big. You might think it's a long way down the street to the chemist, but that's just peanuts compared to space.
Yeah.
Did you get that reference?
I did not.
Chat. Someone's got to get that.
Somebody in the chat. Check my nerd cred, guys.
So the thing is, even getting around our solar system is tough, right? Even getting to Mars or any of these other planets is difficult. With the best spacecraft we have now, to get to even the nearest star to us, which is Proxima Centauri, which is 4.2 light years away, would take about 250,000 years, not the 26,000 years. However, their spacecraft has an ion drive. If you notice, it has not a rocket, it has an ion drive. So changing that to 26,000 is not that unreasonable. Now, they show it flying around all sorts of places. That's just to give you nice pictures, right? That's just to show you, but whatever. But so it's not unreasonable that there could be planets out there that one could live on, but certainly not ones that you would just step out of your cryopod and onto the surface. So that was total sci-fi. We're nowhere near cryo sleep. The problem with freezing people is that, when ice freezes, it kind of expands, and it forms not just that, but it forms crystals. So if you freeze a human being, they might look normal, but every cell has been destroyed from the inside by the expanding crystals like that. So please don't freeze yourself either, because it's not a viable.
So is cryo freezing like a term that is kind of like misconstruing what the actual science is behind it? Is there a way to kind of suspend somebody's natural heart rate?
We can try and slow metabolism and heart rate, but we're nowhere near anything like that. Like, that is completely out there. So that's why I love in The Expanse when they're talking about the Nauvoo, as it's called at the time, before it becomes the Behemoth or Medina Station, taking many generations, even with these 8 Epstein drives, to get to even a next nearest star, right? So this is technology that is so far beyond us still to this day. We've not even got beyond the moon with people, right? We're sending things into space, but the furthest we've got is the Voyager missions that are just at the edge of the solar system, and they were launched in the 70s. So it's not easy. Space is a scary place, and it's huge, truly huge.
Yeah, we've got 2 super chats I want to catch up with. Backyard TARDIS again. Hypothetically, if we send David Hewlett, who is Dr. McKay from Stargate Atlantis, through an artificially created wormhole, what would theoretically come out on the other side?
Now, I told Alex when we started this chat today that he needs to get me in touch with David Hewlett, because that man is a legend. And when I saw you had him, I was so jealous. Like, you need to get me and him talking, because that would be great. Wormholes are kind of interesting, right? So this is another question of people understanding science, and there's a lot of things people have heard the names of, like string theory or the multiverse or wormholes, and they're not necessarily real. They're just sort of fun ideas that we can't disprove. Now, science can't disprove almost anything. That's not how science works. Like, science doesn't, you can't, it's almost impossible to disprove something. You can just say it's very unlikely. So the idea of a wormhole, or an Einstein-Rosen bridge, as it's known in Hitchhiker's Guide to the Galaxy.
Yeah, there's a couple of people in here going, Hitchhiker's Guide. There you go. Yeah, I've never
so
seen
a wormhole
that movie, and I've
would
never
be the
read that
connection between two singularities through a supposed layer of space. We might just call it subspace. We don't even know if that exists.
Okay.
Right? So is it possible that wormholes could work? Yes. Do we have any evidence that they exist? No. Also, even if you could survive entry into a quantum singularity, which you can't, one of the things that we don't fully understand what happens in there, but it seems that while the mass and energy might survive, a lot of the form of what goes in would not be conserved. So you might not like what comes out the other side, even if you could get something out of it. So stay away from black holes, is what I'm telling you.
You're correct me if I'm wrong, but one of your expertise is in black holes, correct?
It was one of the first bits of research I did. I studied the relationship between the galaxies and the supermassive black holes that are at their center. So pretty much every massive galaxy, spirals and ellipticals, have at their heart a supermassive black hole. There's one in the middle of our galaxy that weighs 4 to 6 million times the mass of the sun. So they're not purely destructive. They do play a role in forming the initial gravitational seed, it seems, of early galaxies. So without them, our galaxies wouldn't look the way they do. But it doesn't mean they're a dominant effect in the galaxy's life cycle. Even though these things are massive, because they're so far away, I'm probably having a greater gravitational effect on you right now than the black hole at the center of our Milky Way galaxy. But what we do think they do is probably play a role in what's called quenching star formation. You know, in this movie, when he says, I study dead galaxies?
Right.
No astronomer says dead galaxies. We use the word quiescent because it sounds fancier, but it does mean effectively dead galaxies. So these are the galaxies that have had the star formation stopped by either a catastrophic merger or AGN, active galactic nuclei feedback from that central supermassive black hole. So that was quite a nice. That was quite a nice touch as well.
One of these days, we're gonna have to do a deep dive because I am fascinated by black holes and I know about nothing of them. So I'm always watching YouTube videos that kind of explain how they work, and I'm like, this is so crazy.
One of the reasons they're so fascinating is because I can't tell you how they work, right?
Yeah.
You know, I can tell you some things about them, but the reason they're still in, if I could just give you, they work like this, you'd be like, all right, and that would be it, right? It wouldn't be too exciting. But it's because they do exist, but they're so anomalous compared to all of the forms of matter that we've encountered. That's what makes them interesting.
So we got a comment that says, please ask Tom or at least mention the Pioneer to him. Do you know what that is? Danny, can you be more specific about what the Pioneer is? Go ahead, shoot the comment in there and I'll read it real quick. My last question for you, Dr. Targett. I like saying that.
Professor Targett. No.
Professor Targett, thank you. I even say it with a British accent. It sounds even better.
Everything sounds more scientific in a British accent.
100%.
I kind of tease my students with this in that, sometimes you worry your students aren't, they're just writing down what you tell them without thinking about it. And so sometimes I'll just start saying completely meaningless scientific sounding gibberish in a British accent and see how long it takes someone to say, like, what? Because you can just make it up, right? If I reverse the secondary muon flow through the hydrodyne matrix I could invert the plasma stream to create a space-time inversion in the subspace intermixed layer. And you just keep doing that until someone says, hang on, what? And it's like, hang on, I've been speaking gibberish for like 10 minutes.
Did you just pull out like a full-on Dr. McKay monologue?
I can
just off the top of your head.
I can talk like that for a long time. They're all real science words, right? But I'm just combining them in meaningless ways.
Wibbly wobbly, timey wimey stuff.
Yep. Or it could be an inflection in the space-time continuum, which creates a navigational disruption in the pulsar matrix, which could create a singularity that tunnels through a quantum dimension. You see, it's just gibberish, right?
Right,
Pioneer with Carl Sagan's plaque on it. Yes, yeah. So this is these are when we launched a lot of these missions into space, we put little directions on how to find us for anyone that might encounter it. And there was actually resistance. Some people are like, "Hey, should we really tell aliens like where to?"
That's the first thing that came to my head. I'm like, "You sure that's a good idea?"
Here's the thing: like, if an alien species has the technology to find that, then it's not really about what we could do about it. They could probably figure a lot of this out from just its trajectory. Anyway, they don't need the map necessarily. So if any alien species could reach us, their technology would be so overwhelming compared to anything we could do that it's pretty much irrelevant.
All right, my last question. This is something I've always wondered because I find it to be so like almost unbelievable that you guys can even do this. But as an astrophysicist, when you're looking at planets across the galaxy, how do you know what their chemical makeup is as far as their atmosphere goes, whether or not they're gas giants or they're actual made of some kind of like solid matter? Like, how do we find those things out when they're so far away and all we have is little fuzzy pictures?
This is why I love science, right? Because we've not really been able to take very many at all direct images of planets outside of our solar system. When we talk about detecting planets outside of our solar system, we're usually looking for the effect of that planet on its parent star. Okay. So we're either looking for a gravitational wobble, or we're looking for what's called a transit, which is where a planet would pass in front of its parent star, blocking out even a tiny bit of the light. And we're looking for the little dips as the planet goes round each time, little dip in the light, things like that. So really, we're not looking at the planets, we're inferring the existence of the planets. And this is a key lesson in science, right? Nothing in science is ever right. It's just less wrong than it was before. So when we detect these kind of planets, we're inferring their existence, and we can get some information. So we can get an estimate of the mass of the planet by how much it makes the star wobble. The more mass of the planet, the more it makes the star wobble. We can get a sense of its size from how much light it blocks out when it passes in front of the star. Okay. And if you have its size and its mass, you can calculate its density, because density is just mass over volume. And you can tell if that density is more consistent with rock or gas. And that's how you'd figure out if it's a terrestrial planet, as we call them, terrestrial, meaning Earth-like, or Jupiter-like Jovian gas giant. Because now the atmosphere question is interesting, because that's one of the most exciting things in astronomy at the moment is the launch of the James Webb Space Telescope. Mm-hmm. And one of the things that's going to be able to do, hopefully, is actually measure the atmospheric composition of some of these alien worlds for the first time. Oh, wow. That's going to be we're going to be looking for things like water vapor, obviously. Mm-hmm. But the really interesting stuff is for looking for things like methane and ammonia, which on Earth, at least, are often more present than would be without life on its surface. So we're looking for traces of these kind of things. So, but all of this is another thing I think this movie did really well, is trying to convey to you that idea of science is all about how well do you understand something. He gives the error. This is certain to within this degree, right? A measurement in science is meaningless without a good understanding of how uncertain the measurement is. And that's what we're getting. We're getting better and better constraints on these things. But we don't yet have a really good idea. We've done it a few times with a few worlds trying to measure the atmosphere, but this is going to be happening in the next 5 years. We'll have amazing new results about the potential atmospheric composition of planets outside of our solar system.
That's awesome. So for your final thoughts on this movie, Don't Look Up, on a scientific level, what would you give it out of 1 out of 5 rating for scientific accuracy?
I would give the small details in this movie like 4.5 out of 5. Wow. I would give the big picture stuff, like operating your telescope with the lights on, having comet obviously, like 1.5 out of 5. So that's why actually I really like what whoever the science consultant was. I should look that up, but they did a good job with all the little details. But what they couldn't do was, of course, influence the big picture stuff that needs to be there for the show to be interesting to the audience like that. So I can't praise it to the stars, no pun intended, and I can't rag on it without that sense of balance between the two things.
Backyard TARDIS did another super chat. Thank you, man. You're being super generous tonight. Thank you so much. It says, Alex, do you get this quote? Space is like really, really, really big, dude. Nope, I sure don't, buddy. Oh, man, I'm getting tested tonight.
Overwhelmingly massive compared to almost everything else. Our minds really struggle to understand the size. Even I can't do it. I can tell you that the sun is 1.98 times 10 to the 30 kilograms in mass. But that's a number that our brains can't even process. It's just so I can understand it numerically. I can't understand it physically, right? And it's the same with space. Like trying to get your head around how big space is just beyond crazy.
Yeah. The numbers start getting insane. Ricky, do you have any final questions for the professor here?
I do have one that I'm curious about. I'm here to ask you something somewhat fun. But what is your favorite constellation or star?
So this is good. They do actually mention, when they say, I didn't know Subaru made telescopes, right? It's that's the Seven Sisters, the Pleiades constellation. But fun story with this, the Native Americans actually used the Pleiades cluster as an eye test for their youth, because if you have 20/20 vision, you can see all 7 of the stars. But if I take my glasses off, I couldn't see any of them, like that kind of sense. But when it comes to favorite stars, Probably Vega, which is a star that we actually calibrated our astronomical brightness system around for quite some time. We don't really use it anymore, but in the early days, we had to pick a star to be our sort of reference star, and we compared everything else to that. So, I mean, I guess I could say the sun because it keeps me alive, and I enjoy that. But when it comes to stars in the night sky, it's either Vega for the system or it's the Pleiades, the Seven Sisters, because of their role in their necessary step in allowing us to measure the distance to all the other stars in our galaxy. So there's some really good stuff you can see. I mean, even with the small telescope, you can see some amazing stuff. Like an 8-inch telescope will get you the moons of Jupiter or the rings of Saturn or the phases of Venus or craters on the moon to a great level of detail. So despite what this movie says, I actually encourage you to look up.
Right on. Cool. All right, man. That's it. That's all
All
I
right.
have. All the
I've got one more
questions.
thing for you. Remember?
Yeah, you have a quiz.
I've got a
for
thing
me.
for you, right? So just so the audience knows, if you go back and watch the video I first made my appearance on, I sit down to this interview and I'm all ready to be like, wise science man. And this guy says, well, my audience insists that that I test your nerd cred.
Mm.
And even though we're at a Star Trek convention, he hits me with a Star Wars question, which was like super harsh. And so I thought, okay, you want to play that game? I'm going to hit you with some Star Trek questions here.
I'm not the biggest Star Trek fan. I love Star Trek, but it's not something I'm like fluent in.
This
so
this
is going to hurt.
You did it to me. Okay, now I've got one for each of the 6 original series Star Trek films.
Okay, all right.
In Star Trek: The Motion Picture, V'Ger turns out to be a space probe that was launched from Earth.
Voyager.
What number?
Void. I don't know. I want to say 1, but it's probably not 1. Voyager 5.
Close.
Is it a V or a 4? Maybe it's 4.
Close. It's Voyager 6.
6. Okay. I remember there being a V. I'm like, there's a V, and then like 2 lines next to it.
How many Voyagers did we actually launch?
Oh, I have no idea.
Just 2.
Just
like
2.
We never actually got to Voyager 6.
Why did they number it 6 then?
Because that period of time, we were at this sort of amazing threshold of space exploration. We'd just been to the moon. We were doing all these fascinating things, and the producers couldn't possibly comprehend that we'd just stop and give up.
Okay.
In a way, like that. So that they assumed that would be the first step in many.
Vader,
many
you
things.
have a link to this super chat, dude. Go and hop in here and
we
help
need to get
me
Vader
out.
in here, and he can
help me. He can help me. All right, what's the next
All
one?
right, the next planet. In Star Trek II: The Wrath of Khan, they are exploring potential planets for the Genesis device.
Right.
Which planet did Chekhov think he was landing on?
Oh, I have no idea. I don't even know. I have no idea.
Remember the name of the eel that goes in his? That'll help. It's called the SETI. It's called the SETI eel.
This is literally Matt Vader's favorite movie. I have no idea.
Wait, isn't it like Alpha Ceti 5 or something?
Yes,
like that?
this is SETI Alpha 5.
There you go.
SETI Alpha 6 exploded. And
Vader's
SETI
Alpha Ceti 5. Dude, I'm gonna get so much crap tomorrow. We record our podcast tomorrow morning. Vader's gonna give me so much crap.
All right. In Star Trek 3: The Search for Spock, what is the final destruct sequence for the USS Enterprise?
The final destruct sequence?
They go through, Kirk gives his, it's like, 1A, and then, you get Chekhov's, 2B. But he says, standing by for final destruct sequence, destruct code. And you should say it in the way Shatner would say it.
I have no idea. God dang it.
There you go. Is Vader going to get it? In the moment.
Professor Targett is completely destroying my nerd cred right now.
This is pure revenge for trying.
I told you guys on Tuesday Twitter Spaces. I'm like, I don't watch Star Trek ever. So
oh man,
all these are tough for me too.
0, 0, 0, destruct 0.
That's it.
That's the final code. The Enterprise.
Oh, look at this. Dork Knight is in there in the comments right now. 0.
Yep. Destruct 0. There we go. Okay. In Star Trek 4.
The only thing I remember about that movie is the Ponfar, or that was the next one, the Search for Spock.
That's what we're talking about. That's
the Ponfar moment is by far the best moment of that movie.
All right, in Star Trek 4, The Voyage Home, what are the names of the 2 whales at the Cetacean Institute?
I don't know.
Where's your hydrospam now, Alex?
I can tell you they were in a Klingon warbird. I don't know.
It's a Klingon bird of prey, not a Klingon warbird.
Well, whatever. Here's Vader. All right, buddy.
Vader will know this. What are the name of the 2 whales?
Save me, sir. Save me.
I believe it's George and Gracie.
Excellent. Good. Okay.
Fucking loser.
In
Oh my
Star Trek
God.
5, God, I can't. That's the worst one, so I can't remember the name. The Final Frontier. There we go. What did Spock's father say when his son was handed to him? This is his pain that he has to release.
No clue.
Yeah, I've only watched that movie like 4 times. It was terrible.
That's a wise choice. So human. He's
No
disappointed
idea.
by
Oh
that.
my gosh, man.
All right, a tough one for number 6. How do you say to be or not to be in Klingon?
Takba, takbe.
Yes, that is a man that knows his Star Trek 6. Final question. What is the correct quality order of the 6 original Star Trek films?
What's what?
The
Quality
correct
order?
quality order, like from best to worst.
Oh, that's kind of subjective though, isn't it?
It is, but my answer is the right one.
Okay. I would have to put Wrath of Khan at the top.
I'll
That's
accept that.
Numero uno. And
2,
then,
1, 3. No, 2, 1, 4, 3, 6, 5.
You don't like 6? Okay.
No. I'm sorry. I got that way wrong. 2, 6,
Yep.
3, 1, 4, 6, 5. I think that's got them all.
Okay. You're pretty certain. I go 2, 6, 4, 3, 1, 5. You obviously move 4 down to the bottom. So you don't like the whales.
I forgot 6. No, it's okay.
I love 6. I love 6.
It's okay.
I'm gonna have to take my Star Trek shirt off now, man. I feel like such a poser.
I feel so much better because I floundered for a minute when you asked me that question. And like I just sat down and I'm like, oh my God, what is this guy doing to me?
Yeah, Vader's the Trek
so,
guy.
Like in Salty's defense, his wife is a billion times better Trekker than he is. And we kind of made him go to the convention because he didn't really want to go.
I went to meet the actors. Like I love meeting the people who play the characters in these shows and stuff like that. But I am not well versed in the Trek universe. I casually watch Next Generation and I casually watch Voyager. I haven't even seen DS9, which I
love
know is
DS9.
probably
That was one of my favorites.
Yeah, I kind of saw like mall cops in space for me. It was kind of like they're just stuck in one spot the whole time.
It is a good one. I was at the bar on campus and there was like a quiz night. And I was there like just with my friend, and there's just the two of us. He's a psychology professor. We entered it, and we competed against all these teams of students. But we have like 20 years on them, so we had an advantage. And we go through this round, and it's us versus one other team, and it's like a mostly science fiction themed quiz. So of course that's why we were doing it. And there was a tiebreaker question, and the question was, what odds does C-3PO give for navigating the asteroid field? Now I actually have this.
Yeah,
I actually have this in you mentioned before we started my Myths of Astronomy talk, which is a talk I give about things that people think they know about space from film and television. And that's one of the things I have in it. And it's like, yes, all of my career has built to this moment because I know that the odds of successfully navigating an asteroid field are 3,720 to 1. So it was just, this is the kind of knowledge that I love, my brain scores.
My trivia knowledge it's gone now. As far as Trek stuff goes, it's really bad anymore. But I'm still glad I can do a takba, takbe.
That was good.
That was dope, dude. That was really cool.
I knew that Alex wouldn't get it, but I'm glad you came on.
No, you completely pulled the veil off of my freaking nerd cred, but that's all good. All right, everybody, thank you so much. We've gone 20 minutes over our normal hour show. Thank you all for being in the chat. Tom, thank you so much for being here. Professor Targett, it was wonderful to chat with you, and I'm really looking forward to working with you again. And
My pleasure.
I will absolutely reach out to David Hewlett and see if I can get you guys in a chat room together.
Yep, we need to talk Star Trek, The Expanse, and Stargate. These are my special topics that
these are the kind of things that happen on like a celebration stream for like 5,000 subscriptions.
Oh yeah, maybe we can do something like that. So guys, we're really close to that milestone for the 5,000 subs on YouTube. So if you haven't already, most of you guys in the chat have. But shout it out, let people know, share it with a friend. Like, hey, if you like science, if you like nerd culture and stuff like that, just share it with one person. Help us reach that milestone. We'd really appreciate it. And again, if you want to support the podcast and be a super awesome club member, go to saltynerdclub.com. It's only $5 a month, and you guys get access to an absolute ton of content, including a 2-hour podcast with David Hewlett talking about Doctor Who. So if you are into that kind of stuff, head over to the club memberships and come hang out with us over there, man. It's a cool place.
I am a Salty Nerd member. I can vouch for it. There is a ton of content that these guys put out. It's a phenomenal deal for $5. So yes, please.
We have a $30 tier too. It works really well.
Yeah.
Ricky, speaking of, thank you for coming tonight. Where can people find your podcast?
You can find me over at, as the name says right there, After the Weekend. But I recommend you type it in as one word. That seems to be the best way to find us. And we're a movie review channel. We focus on movies from the 80s and 90s that we grew up with. I have a co-host. Her name's Maria. She's the Geeky Crochet. But yeah, you can find us over there.
Right on. And Professor Targett, you said you're not on social media, but if there's any way that somebody might want to support you, where's the best place for them to go?
You can find me at the Salty Nerd podcast.
Right
My life has been 10 times better since getting rid of social media. I try and focus more on like family and work and stuff like that. And I know you guys are, you're a media group. You're going to have this presence, but I think it's because I'm old now. I don't need social media, so that's not a problem.
All right, so you can actually it's pretty accurate. Then you can find him here at the Salty Nerd podcast. This is not the last time we will have Professor Targett with us.
Our resident real scientist.
Yes, yeah. Whenever we need to check on something, my wife is in the chat right now. In March, we're going to be discussing the TV show Eureka, which is that's a great science fiction show. I'd love to talk with you about that as well. But Vader, since you showed up, buddy, why don't you let people know where they can find you and what we got going on over at the podcast?
Oh well, it's right there. It's Matt Vader 74 and all the socials, and over here and on our Discord, saltynerddiscord.com.
Right on.
Everybody knows where I'm at. So yeah. Thanks.
And tomorrow morning, guys, we're going to be live on Twitter Spaces. Follow the Twitter account at salty_nerd. We're going to be live talking about zombie movies, and there's actually a meteor in one of them where the meteor comes and it turns everybody into zombies. So check it out. We'll be live on Twitter tomorrow. You guys can listen to the raw, unedited version of the podcast. All right, everybody. Thank you guys so much for joining us tonight. I really appreciate all the support in the chat. You guys were fantastic. Thank you. And again, Dr. Targett, it's awesome having you on. I love
my pleasure. Thanks for
real world scientists coming on talking about nerd stuff. This is fantastic. This is what I dreamed about when I started this podcast. But that's it, everybody. Thank you guys so much. Have a great night. We'll catch you guys next week.
Kapla.